In this video, we're going to be dividing polynomials by trinomials. So if you'd like to review how to divide by a binomial, there's a separate video for that. Now, we're going to start with examples 7 and 8 on our notes. We're going to start with number 7. Now, as usual, you put the divisor, which is x squared minus x plus 1 on the outside. And you put the dividend on the inside. But first of all, check. Are the powers in descending order? I have an x squared missing, so I need a placeholder for that. So I need to put x to the third plus 0x to the second plus 5x minus 4. And you do the same steps. X squared times what would give me x to the third? It's x. So you go ahead and multiply the whole thing by x. X to the power 2 plus times x would be x to the power 3. Negative x times x, that's negative x to the second. And 1 times x, that's an x. You see how the powers are lining up? Because I have the placeholder. Don't forget to distribute the negative since I have to subtract them. So this is going to be negative, this is becoming a positive, and this will become a negative. Now, if I'm multiplying correctly, the x cubed minus x cubed should cancel out. 0x squared plus x squared, that's going to be 1x squared. 5x minus x, that's going to be a 4x, and I'm going to move the negative 4 down. Now I need to ask myself, again, x to the power 2 times what would give me x to the power 2? That's only going to be a 1. So if I multiply all of this by 1, it's going to be itself. So I'm going to copy it down. And since I'm subtracting, I need to change the sign. So x squared minus x squared will cancel out. Plus 4x plus x, that's going to be a 5x. And negative 4 minus 1, that's going to be a negative 5. Now to decide if we need to continue dividing or not, we have to compare the powers. If the power over here is less, then the divisor means I'm done multiplying or dividing. This is a power 2, the degree is 2, here the degree is 1, so I'm done dividing. So all of this is going to be my remainder then. So my final answer, when I divide, is going to be x plus 1, which is the quotient, plus the remainder over the divisor, which in this case is x squared minus x plus 1. And this brings me to discuss with you, remember when we were doing horizontal asymptotes and we get to bot node, like bigger on top? So x squared plus 5x minus 4, this is just a thought for you. So bigger on top, so there's no horizontal asymptote. It's because there's something called a slanted asymptote. And this one would be the slanted asymptote, the x plus 1. Now, this is again something you're going to discuss later in pre-cal, but it's good for you to know from now. This is why we do long division. We do long division to get to the slanted asymptote, or in order to be able to factor if the remainder is 0. So my final answer, and the only thing you need to learn in Algebra 2, is that this is how you write it down. Now let's move on to example 8. Again, I put the divisor, which is 3x to the power 2 plus 4x plus 5 on the outside. And I put the dividend, but let me check if it's in descending order. 5, 4, 3, 2. Oh, there's a power 1 missing, and then the constant. So I need to write a placeholder for the power 1. There you go. Now, 3x to the power 2 times what would give me 6x to the power 5? That's going to be a 2 to give me the 6. And then x to the power 3. So 3 times 2 is a 6, and x to the power 2 times x to the power 3. Since I'm adding the powers, that's going to give me 5. So that's 6x to the power 5. And now 4x times 2x to the power 3 is going to be 8x to the power 4. And then 5 times 2x to the power 3, that's going to be a 10x to the power 3. Now draw a line and change the signs. So 6x to the power 5 minus 6x to the power 5, that's going to go away. x to the power 4 minus 8x to the power 4, that's going to be a negative 9x to the power 4. Now plus 10x to the power 3 minus 10x to the power 3, that's a 0, so the x to the power 3 canceled out. Now you can put a 0, but again you'll mess up later on when you multiply. So since there's already a power 4, you still have to have the powers in descending order. So you have to put in the 0x to the power 3 as a placeholder, because you still need the powers to be in descending order. Let me copy everything down. Now ask yourself, let me push it or zoom out. Okay, there you go. So 3x to the power 2 times what would give me negative 9? So that's a negative 3, and then I need an x squared. So that's going to give me negative 9x to the power 4. And then 4x times negative 3x squared, that's going to be a negative 12x to the third. You see how the powers are lining up? So if I didn't put the placeholder, this could be under the 2, and then I'll make mistakes combining like terms. So since I have a 4, I had to put in the placeholder for the 3. So still I need them in descending order. And now 5 times negative 3, that's going to be a negative 15x to the power 2. Draw a line and change the signs. This should cancel out. 0 plus 12 is 12. Don't forget the x to the power 3. Negative 14 plus 15 is a plus 1 x to the power 2. And move everything down. Now, 3 times what would give me 12? That's a 4. So 4x. So 3 times 4 is a 12x to the power 3. And 4x times 4x, that's going to be 16x squared. And 5 times 4x, that's going to be a 20x. Draw a line and change the signs. So if you want, just write it on top so you don't get confused. So this should cancel out. 1 minus 16 is a negative 15x to the power 2. 0 minus 20, so that's a negative 20x minus 25. Now, where are you going? Okay. So 3 times what would give me 15 or negative 15? That's a negative 5. So 3x to the power 2 times negative 5, that's a negative 15x to the power 2. And 4x times negative 5, that's a negative 20x. And 5 times negative 5, that's a negative 25. Now draw a line and change the signs. This cancels out, this cancels out, this cancels out, so my remainder is a 0. So that means that this is a factor. This is a factor. So this is a way for me to factor. Long division and later on synthetic division are also methods to help me factor my polynomials if they are of a higher degree. So to write it, you say that all the dividends equal to the divisor times the quotient. And since there is no remainder, I don't need to add and divide by the divisor. And that's going to be my final answer.